Hello, everyone, and welcome to Cloud Launch and Learn. We have a special guest today. We have Warner Chaves. So he's going to help us to understand more about modern data and analytics that comes and plus how you can use them on Microsoft Azure and Microsoft platforms. And this is going to be very great session. I believe there will be demos, but Warner, do you want to introduce yourself and speak about that?
Yeah, absolutely. So thanks everybody for joining me today. I don't know wherever you might be in the world. It's about 1 p.m. for me right now in the east coast of Canada, and very excited about this. Yeah, we're going to talk about architecting a modern analytics data platform. We have a bunch of examples here, diagrams, and we're going to talk a little bit about stuff that is trending right now in the industry as well.
Awesome. So I hope everybody is excited about that. That's we are going to roll now, and I'm going to go to the backstage now, and we will share the screen here. And Chavez, it's all yours. Please put on a presentation mode and let's roll it.
It's good. You see it right now?
All good. Yes, it's there.
Okay. So everybody, thank you again for joining me today. And allow me to introduce myself. My name is Warner Chaves, and I've been working for doing database administration and consulting for 15 years. And I used to work at Hewlett Packard in Costa Rica. I work now for a company called Pythian in Ottawa, Ontario, in Canada. I do solutions architecture. I'm honored to be a Microsoft Data Platform MVP. Feel free to reach out to me on Twitter at warchaf or LinkedIn. Just look me up by name. Check out my blog and website, createdatapros.com. If you think about something after as well, you can shoot me an email. I try to get back to everybody within a couple of days. Warner at createdatapros.com. And my employer, also Pythian, has a pretty cool technical blog that covers way more than Microsoft. We cover Google Cloud, AWS, open source technologies, data governance, data strategy, the business side of data as well. So, the agenda for today, we're going to discuss the main components of modern analytic platforms and go through the design thought process, some of the common use cases, some of the lessons that I learned as I applied some of this stuff. This is a beginner session from an architecture point of view. So, we will go through the diagrams, discuss the different components, but we just don't simply have enough time really to drill down into why each specific component is selected for any particular example, right? But we will go through in high level on all the different diagrams, okay? So the session is structured to go like this. I'm going to talk a little bit to set the stage about the current challenges of creating analytic systems and why I recommend people mostly do them in the cloud today and they follow the patterns that we're going to go through in the slides. There's a bunch of different example architectures that we go through, discuss, what I think they get right, why people are selecting some things, if there's anything interesting. Most of them are reference architectures from Microsoft. Others are from Databricks. I have some general architecture from the official data mesh um, book, and probably a lot of people are interested about that as well. There's a lot of talk lately in the industry. I just mentioned that we're talking a bit about what's trending right now, and this whole idea of data mesh. Every time I logged into LinkedIn or Twitter, everybody's talking something. Somebody has an opinion about this data mesh pattern. And then I have some lessons learned as we go along through the architectures, right? If you have any questions, feel free to post them. We're going to hold them till the end. At the end, I'll leave about 10 minutes or so just for dedicated to questions. So don't worry about it. We'll get to it. All right, prerequisites. To order to understand and follow the session, I don't think you need to know a lot. You just have to have some basic experience with some analytics. Maybe you've done some BI tools, either, they develop a little bit of ETL. You've done a little bit of reporting. You've worked with some little bit with warehousing or data marts, etc. So basic knowledge of BI components. That's all you need. Now, again, let's set the stage and everybody get on the same page. What am I talking about when I say architecting a system, right? So software architecture refers to the fundamental structures of a software system. And obviously building an analytics platform is a software system at the end of the day. So we want to identify the right combination of software, tools, and services and how we're going to integrate them, right? So that's pretty much what it is and what I mean when I say the architecture of modern data platform. What are we going to use? How are we going to integrate? What are the advantages of these different building blocks that we will select, right? Now, why do I think this is very important? Not just I, but in general, good architecture is a best practice, of course, that you really try to get your architecture right. And the reason for that is that if you have been working in development or consulting or building projects, implementations, you know this, right? If you get the early work right, so if you pick the right tools from the beginning, it is a lot cheaper than fixing it later, right? So if you didn't do your architectural homework and you started to build something that at the end did not have the right architecture for your requirements, it's going to be really expensive to go back and replace the core components once you figure out that they're not really good for your requirements. That's a big costly mistake, right? So we want to get the early work right so we don't have to go back later to fix it. Now, what are the current challenges of modern analytics systems? So this is what we usually face today. If you're with me in the analytics industry, or you're maybe in the data industry in general and interested in going into the analytics, maybe you're a DBA and you're starting to get exposure to the analytics landscape. Usually, you see this, right? Everything's growing. The sources of data are all more and more things, and business keeps finding more use case for different sources of data, right? We used to have just operational systems. Now we have operational systems and social media and Google Analytics and everything you can think of. Data is all over the place, even though data governance is getting more popular. It is even getting established in some more mature companies. For the most part, this is a real struggle for most companies. User expectations, everything is more and it has to be faster, right? More data to be able to make better decisions, and it has to be faster, fresher, so they can have a more up-to-date view of what's happening. User expectations also moving towards more interactivity. So this is where I think the visualization market has really changed quite a bit in the last few years, right? We used to have products like SQL reporting services or Cognos, or business objects that were more like paginated, kind of like static reporting. And obviously, Tableau came in with its capabilities of interactivity, the automatic filtering when you click on a visual. All that stuff that's Tableau established has been picked up by all the competitors, and now we have a big amount of viz tools that for the most part all follow the same patterns. Tableau, Power BI, Click, Looker, for example, just to name a few. So that's where the front end piece of the analytics platform is moving towards, right? More interactivity. Obviously, there's still a use case for static reports, especially for things like finance and stuff like that. But just for ad hoc and analysis, interactivity has become very important. And on top of all these things that are already complicated enough, we also have to think about security requirements, because this is so important nowadays as well, right? Everybody wants to make sure that their data is safe. Nobody wants to be on the news because they got hacked. And on top of that, governments have created all sorts of regulations and standards that you have to adhere to be, avoid getting fined or put out of business by the government, right? We're talking about, we have PCI, we have SOX, we have HIPAA in North America. Over in Europe, we have GDPR. If you're working with government offices sometimes have their own standards that you need to apply. If you're working in defense, military, etc., right? Lots of different things. Now, I do want to stress a point here, and it is about, I say a modern analytics data platform. I didn't want to make it 100%, it has to be cloud, but I have to say that these architectures could be replicated on premises. So most of these things, the different building blocks, have some sort of equivalent product, either a commercial or open source product that you could do on premises yourself. But I have to say that I think, you know, the cloud is many things, and the cloud was promised to many people as many things, right? And a lot of those promises turned out not to be really true. A lot of those promises are kind of still playing out. But this is one promise of the cloud that I do think is true. and I think it is a game changer for BI and analytics projects. And I'll go in why, and why my examples. I've been presenting this material for a while, and I used to have some on-prem examples using SQL Server and whatnot, and they're completely gone now. I have my examples here. Even though you could do them on-prem, they are all in the cloud. So why do I think that? Well, because on-premises projects, when I used to do them, and honestly, I haven't done an on-premise analytics project for probably like 5 years at this point. So they're not very popular anymore. But when I did used to do them, a lot of them had a lot of issues. They would stop, and after a lot of money was spent, and there was nothing useful. So there was some technological result, right? We have this warehouse and whatever, but nobody was actually using it. So the results were not really useful. Um, the projects were complete, but they were very late. They were complete, but they were like way over budget. Even if everything looked right, as soon as the project ended, after a while, no one was using them. So, long-term view, the project wasn't really that successful. And the reason for that is because getting on-prem BI projects to work require a lot of investment, hardware, software, licensing. You have to forecast what you need very accurately, because you have to, go out and buy actual hardware and go out and buy actual licenses and software. You have to know how to manage all the infra, all the products, right? All the software, all the storage, all the network, etc. And you require your IT to be really quick and agile to keep up with all these moving pieces, right? Just not just the technological platform, but also the users, right? The users will ask a lot of stuff from IT, and IT kind of is like a gatekeeper for a lot of these things. So if you look at it, the way that I look at it, and like I mentioned before, I think the industry looks at it this way because, from a consultant and solution architecture perspective, I haven't done an on-premises analytics platform project in a long time. So on-prem is a big cost up front. In the cloud, you can move it into an ongoing cost, so it's not as bad right off the bat, right? In on-prem, you have to have an accurate forecast when you begin. In the cloud, it's elastic, so you can try to guess what you're going to need at the beginning. If you're wrong, it's not that bad. You can go up, you can go down. You need a lot of infrastructure expertise on-prem. In the cloud, there's a lot of fully managed services for the analytics side that you don't have to know anything about the underlying hardware. There's longer development cycle on premises. In the cloud, people adopt more agile development methodologies. Now, on-prem, you could adopt some of these things, but the cloud just makes it so much easier to adopt, right? Templates for deployment. You can create and destroy resources for testing, for development, for prototyping. The services come pre-integrated by the cloud vendors, etc. Right? So this is how I follow the architecture methodology. Then I start. First of all, I only try to architect systems where I know the stack really well. I think that's critical. Obviously, if you're going to do architecture, is that you know your stack really well, because there is a universe of different choices into how you build a system, and you want to be able, like I said, to get the early things right, so you don't have to go back and fix any mistakes, right? So know your stack. If your company, obviously, my examples here are going to be with Azure, but if your company is, let's say, focused on Google Cloud or AWS, go up, study it up, get certified, etc. Gather your requirements, make sure you talk to everybody that's going to be using it or that has a stake on the system being built. Very important for BI and analytics. And then this is what I do. I select components based on functionality, cost, and experience of the people that are going to be working with. So number one, I want to make sure that the requirements are met. Number two, if I have the same component for the same requirements, I will consider cost at that point. I am not going to automatically um, cut requirements based on cost. So I wouldn't put cost as number one, right? Like some people might say, like, oh, you just focus on making it the cheapest thing possible. I disagree with that, obviously. And at the end of the day, a lot of projects actually fail because assumptions were made to cut cost that cut on functionality that was critical, that ended up with a system that was not adopted. And that is even worse, because it's not even a system that might end up being a little bit more expensive down the run. It just ends up being a total waste of resources. And last, if I have, let's say, a couple of components, they both meet requirements, they cost exactly the same, then I will look at what the people that are going to be working with it are familiar with. Are they familiar with one over the other? Do they like one over the other? Does the company have a better relationship with one vendor over the other? Or do the users have a preference of one over the other? And then we can select a component based on that. Very important to know your stack again, because I want to illustrate how when you build an architecture, you have to go through a big tree of multiple choices for every component. I'm just going to use one example here, right? Let's say I figure out my architecture needs a database engine. Then it's like, well, is it going to be a SQL database engine, or is it going to be, if it's going to be a SQL database engine, do I need a single database? If it's a single database, do I want to put them in a bunch of elastic pools? Do I want to make it a hyperscale database? And this is just in Microsoft Azure, right? If I want a SQL database, do I want an instance instead of a single database? Maybe I want a single instance. Maybe I want pooled instances. So you can see even just, oh, and then the other choices, maybe I don't even want SQL. Maybe I want NoSQL, right? So even for just one choice, such as database engine, I have all of these different things I can select from. And this is where again, knowing your stack is really important so that you don't end up selecting a component or a configuration that was not really what you needed. I had this actually, I do calls all the time with clients that are, potential clients for Pythian, for example, where they come in and they have major issues with their systems that they have deployed, and we're trying to help them figure out, remediation, a way to get out of their problems. And a lot of it is because they're just not using the right thing for what they're trying to do. I've had clients that use distributed OLTP NoSQL products and just trying to do analytics on top, and it doesn't work, or it works but it's so expensive, and the clusters have grown to like these ridiculous sizes because of that. um, and then the opposite happens as well. Clients that pick MPP analytics engines, and then they're almost, running updates and deletes on them all the time, and then same thing, either the cost runs up or the whole thing just doesn't work, right? Again, because they did not do the proper tool and service selection. Okay, so with all that said, let's dive into some examples. So these are some basic architectures that I'm going to start with. By the way, great references, especially if you're in the Microsoft space. Regardless, all the cloud providers have this. Just go on Google. You can search for this. If you are working on Google or AWS, for example, you can find the same. They have the same kind of material and reference online. But Microsoft has a couple of really good ones. One is the Azure Architecture Center, is the top link, and that one goes beyond just data analytics. It's architectures for anything that you can think of. Is if you want to build like, microservices, if you want to build still want to build like a 3-tier application in the cloud, if you want to do IoT, if you want to do I don't know, mobile app development, and you want to do NoSQL for it, etc. There's so many example architectures you can use. So that's one. Second, Microsoft has this thing called the Cloud Adoption Framework, and it has a scenario called data management. And this is basically a big document that goes through almost like step by step into Microsoft's reference architecture for analytics. And I'm going to go a little bit into it later on in the slides as well. Okay. All right, so this is the first one, the first architecture that I want to cover today. And this one, Microsoft calls it an automated enterprise BI with Azure Synapse Analytics and Azure Data Factory. Okay, so we'll see here. We start with a couple of data sources, an on-premises SQL database, and some external data that we don't know where it's coming from, but we know it's file-based, right? And then it says, okay, well, we're going to do the orchestration in this way. We're going to ingest into blob storage, then we're going to move into Synapse, and we're going to orchestrate it through Data Factory. Now, right away there's already an interesting architectural choice, right? Because Data Factory can read files. Data Factory can also read SQL servers, and Data Factory can write into Synapse. So why are we using this here in between? Right? Microsoft recommends that you use some sort of storage in between, and there are different reasons for it. And this is a pattern that I have adopted as well for the majority of my clients. So I'm going to go into a few reasons why you want to do this instead of doing, straight from here to there. First is because there might be some data that you remove on transformation or that you get rid of transformation, and you want to still keep the raw initial image of it on storage. And I'm not going to say keep this on hot storage, right? You have to take advantage of the cloud here. And this particular piece, maybe after a couple of months they move into cool storage, and after that they move into like the archive coolest storage, so it's really really cheap as time goes on, by the way. But there is definitely use case for having that storage account here. One of them, as I said, is because it allows you to always keep that initial raw data. Second, in case you want to come back later and you want to reprocess the data because something changed here, like as I mentioned before, requirements, they're very dynamic. Users have a lot of different things they like to see, and maybe some of things that you aggregated or that you did not import the first time on your warehouse inside, now they want them. So instead of having to go back again to your source systems, now you just load it straight from cloud storage and you're off to the races. So that's another reason why having this intermediate cloud storage is a good idea. Another reason why you might want to have it is because there's a lot of different tools. Maybe your ETL cannot be done through Data Factory, even though Data Factory has a lot of connectors. Maybe Data Factory just doesn't have the connector for the tool that you want to use as the source. So storage, cloud storage is so common nowadays. There's so many tools to upload to cloud storage and make it easy. You can always do like, let's say you have some sort of legacy database system that doesn't have any sort of connectors. You can always just run like a job that exports that into just a file, and then from just the file just copy it into blob storage and you keep it that way, right? So that's another reason why you might want to do it. And of course, maybe you want to have you have some other staff, for example, that likes to use Spark. I don't have Spark in this particular architecture, but we will have it in another one. um, Maybe and Spark, obviously you could connect Spark to Synapse if you wanted to, yes I know, but then you have to have Synapse up and running too. It's more expensive as well. So you could enable these people to just connect Spark straight into the cloud storage and run their Spark queries if they wanted to on cloud storage as well. So there's a lot of use cases here for having this intermediate cloud storage too. Now, if we keep going forward here, then there is another interesting choice in this architecture, and it is that they are saying, well, let's put analysis services on top of Synapse. Um, and here, it's, the idea is that you would build a tabular model on analysis services to then consume it through Power BI. Now, there's reasons why you might want to do this or you might not want to do this, right? Um, Synapse is an MPP engine. It can do a lot of things very well, but depending on what you're trying to do, analysis services might be doing it better. For example, if you're trying to do something like year over year comparisons, is a lot easier to do that in analysis services than doing it on Synapse, for example, right? And writing the SQL to try to do that and coming up like with all the different scenarios for what the users might do. That's a lot easier to do in analysis services. And then Power BI, you can connect it to either one. You can connect Power BI to a tabular model. You can connect Power BI to Synapse as well. But if your users are not really like ad hoc running queries and they are mostly, they like to see the same type of, analytical view of the data, and they just slice it in different ways, it might be more cost effective to just have the tabular model populated, let's say in the morning, and then you leave that tabular model for people to use during the day, and then your MPP warehouse, the Synapse engine, the SQL pool, is only up and running overnight, and then the rest of the day is paused, for example. That could be a valid use case as well, why you would want to bring in um, analysis services. And then the other thing I just want to point out, Microsoft does put here Azure Active Directory. These components, do not underestimate these components, right? These components are core components, right? They're not something that is literally part of the solution in the sense of like the data is not really flowing to Azure Active Directory, right? But without this kind of stuff, like without the right authentication, without the right network, without the right monitoring, all this stuff that it might not be really for data architecture. It might just be general site or systems administration kind of architecture. All these things have to be working, or all these other stuff is not going to work. right? If you don't have your Azure AD properly configured, populated, etc., then you're not going to be able to develop this at all. So don't underestimate this either. If you have a somebody else that's not you, that is the admin of, the Azure AD and all this stuff, don't get in their bad side. You're still going to need all these people to help you, build your analytics system. Right? So some fundamental components right off the bat that we see there, right? Storage, as I mentioned, the relational engine. And I still find that most people will want to do some SQL querying. Most of them will benefit from modeling in tables and columns, and for the most part, try to avoid denormalizing things. Denormalizing things where you are repeating values, I find that's fine for analytic systems. Denormalizing things where like you have, let's say, objects inside columns and stuff like that, I find that makes it a lot harder, and I don't necessarily see the advantage of doing that for analytics systems, right? I think that might even be more confusing for users than anything. ETL, you're going to need something to do, extract, transform, load, or extract, load, and transform regardless. But you're going to need some sort of component to extract data and put it in a different place, right? Orchestration, a data factory, in this case, in the Azure example, you're going to need something that can trigger jobs, that can do different things based on the outcome of a step and things like that, right? And then last, visualization. This is where, your organization will probably have some sort of a standard tool. It could be Power BI, it could be Tableau, it could be Click, it could be Looker. It could be really much, pretty much anything. Um, there's so many tools nowadays, but definitely most likely you will want one. If you're building a modern analytical platform, it does not make a lot of sense to just, you build this thing that's all cloud based and it has all these modern components and, something more like an MPP cluster engine like Synapse, for example, and then you just connect it to like reporting services. It kind of like, it kind of loses its appeal, right? And you want to get the users excited for it. So pick a nice Viz tool. Hopefully you have somebody, if you're really good at making nice visuals, that's great. If not, hopefully you have somebody to help you to really make the visual part pop as well, because it's really, I find that's really good for getting the users interested in the systems too. Okay, this one Microsoft calls it an advanced analytics architecture. It has a couple of different things from the one we just saw. So we still have this part where we do the ingestion, we have a business custom app, we have some unstructured data here, logs, files, just like the previous architecture had some mix of SQL and files. We are using still Data Factory for ingesting. We're still using Azure Storage for ingesting. Now, the difference here is there's couple of differences here. So you see here the architecture so far up to here is the same, right? You'll see the new part is this lower quadrant here. So what this is saying is load the data into Azure Data Lake storage, and through Polybase, right, through just the Synapse technology for loading from storage, you populate your data warehouse, you populate your tabular model, that's all good. But you can also leverage Databricks, for example, to do a lot of really cool, not only data science, right, by using Python, Scala, Java, whatever you want to use, or just SQL. You can also do a lot of ML, for example. And the cool thing about this is this architecture has this idea, which I like quite a bit, that is using Cosmos DB then to feed a web application, right? So this is usually when we think about the end users of analytics, we think about this, right? Like, oh, we want people are going to be sitting in front of reports or in front of dashboards, and we're going to serve them through Power BI and whatnot. But we kind of forget sometimes about this other side of analytics, right? Is the side of analytics that you can actually use for live applications, right? Every day that we go on online stores, we get bombarded with recommendations of stuff, and that's all analytics, right? um, and that's just one use case, right? Recommendations. Think about all the stuff that Netflix suggests to you, or the music that Spotify, or when you shop in Amazon, right? Um, Same as we do recommendations, we could do other things, right? You could do like targeted advertisement, right? You could say, okay, I'm going to show somebody this a different banner. And if they click on the banner, that's going to go into my data. And then next time I create my ML model, it's going to know that the banner was clicked. So it's going to favor a banner that's kind of similar to the banner that they used to click before. And so I'm going to populate a record here on Cosmos DB that says user X. Let's load up banner 38 next time, and then it'll go into the web application. The web application will pull down banner 38, right? And then banner 38, oh, they didn't click on it, so that lack of a click is also gets recorded in the app. Oh, there was no click on the banner this time. So the ML model can calibrate next time and be say, oh no, so let's just decrease the probability of getting at 38. Next time let's feed them another different one, stuff like that, right? So you can do really cool stuff from an app perspective too, not just from user facing BI. Okay, all right, let's keep going. So as we saw, that advanced architecture, it has some augmentation from the previous one. So there's a few components that are commonly added to architectures that have to do with data, right? There's big data compute. In this case, it was Databricks. I see this quite a bit. Either Spark, either open source Spark or Databricks are very popular nowadays in the cloud, of course. And that's commonly added as well. We have also vendors like Snowflake, for example, that are embedding this right into their product, right? Snowflake, instead of having separate Spark clusters, Snowflake has this capability called Snowpark, where you can run Python, Scala, Java, all against the same clusters in Snowflake that also do SQL, right? So it's really cool. So this big data compute idea is usually you find it somewhere in the architecture nowadays. ML, of course. First it was data science, and now more specifically machine learning has gotten quite popular. And not a lot of people I find are still doing it continuously, but a lot of people are starting to prototype a lot more, trying to find use cases in production for it. So it is pretty common to find this as well. That somewhere in the data model, or sorry, in the data architecture, there's ML training and scoring happening. Something that I used to see this a lot more on-prem, where people always had to build cubes because their database engines would not be able to handle what people wanted to do from the cubes or from tabular models. I see it a little bit less now, but there's still every now and then a use case for an OLAP component. A lot of it, data cataloging nowadays really big, as well as people start to establish more data governance. So tagging of fields, especially with stuff that is sensitive, tracking the lineage of fields, what systems they're coming from, and all that stuff. Microsoft, for example, Azure has this thing called the Azure Purview. That's Microsoft's data catalog and dictionary and lineage tool. There's a lot of third-party tools for that, though. Some of them really expensive as well, and very popular, right? You can find vendors like Calibra, Talent.D, Elation, Informatica, so much. Um, and the first party vendors, like I said, Microsoft, for example, has Azure Purview. I forget, I think AWS has the Glue catalog, and it's also embedded inside Lake Formation. Google has the Data Hub, and the Data Hub has also a catalog component. So there's a lot of this is getting very popular around the industry. And then you can find other stuff, right? For example, if you have images as part of your analytics, you could do OCR on text. You could do Microsoft has these thing called the cognitive services. Again, AWS and Google have similar stuff where you can do image recognition. If you're storing images, you can do things against sound files, against video files. You can do a text analysis, etc., etc. And this is the part where I said don't underestimate this part. All the supporting components, they have to work, they have to be good, they have to be well architected as well, right? So identity and access, the networking, key management, the logging and monitoring. How are you going to track all the issues? How are you going to monitor your solution? Um, you might not be the one responsible for this if you're a database administrator or a data architect. Um, Usually, even myself, I can't say that I'm like an expert in networking. I'm not. I usually have somebody work with me in actual projects to help with these parts, right? To help me do the right choices for identity and access management. I usually tap into somebody else for to help me do the right choices for networking. I find somebody that has that level of expertise that I need to make sure that these supporting components do not get overlooked. You don't want them to get overlooked. Okay. Oh, and CI/CD as well. So if you can establish a DevOps pipeline to make your development processes more efficient, you want to do that as well, of course. Okay, so here's another type of architecture concept that's been mentioned quite a bit. Microsoft has it as a big part of their cloud adoption framework for data management. And it's this idea of concept, an architecture of data zones. So data zones are resource boundaries. So you organize the data based on where the data is in the pipelining process and for controlling the different access to data, and if the data has different sensitivity requirements, all these things, you can control it through this architecture of multiple data zones. Okay. And then the data zone boundary, depending on your requirements, how big your organization is, how mature it is, you might have complete network isolation. And this is actually what Microsoft's architecture does. So different data zones have completely different VNets, virtual networks. Or if you're a smaller shop, you like this idea of the data zones, but you don't want to, make it too complicated, have different virtual networks, etc. You could do it with just storage isolation. Something like, let's say, different storage accounts, maybe different SQL pools if you're using Synapse Analytics. You could do it that way as well. Or if it's a really small solution, but you still want to have some nice, bookkeeping, keep everything tidy and clean, then at least you could have the container isolation, right? So different containers, one storage account, but you have different containers for the different type of data. That's like the bare minimum, right? Obviously, and the different databases for different type of data as well, right? Microsoft, like I said, their reference architecture is to use different virtual networks, and we can look at that. So you see here, Microsoft splits their cloud adoption framework into two main components. One is this idea that you create a VNet called a data management landing zone, and then connect it to this data management landing zone. You see here, here's an example. It says this is the sales data landing zone. And we don't know what this is really. It's kind of like a black box in this diagram. In the next slide, we're going to zoom into this one. But you see here, there's a VNet peering between this zone and this zone. And this zone that I have here, the one that is called the data management landing zone, is basically to have all these services that will work for all the other zones in service of all the other zones, right? So we have private DNS zones here. We have the networking setup here. We have Azure Purview as the integrated catalog on this side. We have the network watch, we have the security center, all these core components. You put them in this data management landing zone, and then you connect the different data landing zones to this management zone. Okay. And then the actual data zones, they look like this. You'll see this one says sales data landing zone, and you can see it's basically the um, kind of like the advanced architecture that we saw becomes this idea of a landing zone, right? You'll see here we have the networking for this VNet, we have the monitoring, we have the ingest and processing. This example again is using Databricks. We have different data lakes for the different category of data as it gets processed from raw, enriched to the workspace data. Um, we have key vaults here. We have some meta stores as well. And we can see here, for example, in terms of orchestration, we're using Data Factory. Here, it's even going further. It says, oh, well, we have a type of data that is the sales transaction, and we have a type of data that is customers, and we're even going to give them separate data factories and separate key vaults. Now, to me, this is an example from the Microsoft reference architecture. Now, to me, separating it this much is probably too much for most people. Unless you have some really stringent security requirements, this you can probably merge it into one. This could be just one data factory, one key vault, and use it for both of the sources that are being used for this data landing zone. But again, these are example architectures. once you understand the criteria and the reason why they are built the way they are, then you're empowered to modify them yourself, right? And then the idea here, the actual data product is, a data set inside Synapse Analytics. So this is the idea with the data zones. And um, as I mentioned before, Microsoft examples, they all use actual virtual networking as the boundary of the different data zones. So just as we have this sales data landing zone, you would have, let's say, for example, a finance landing zone, or you could have an HR landing zone, and they would have inside something similar to what we have on the screen there right now. Okay. Now, another term that gets thrown around a lot lately, lake house, and people use it for all kinds of things that are not even actual lake houses. All right, so what's a data lake house? So let's go back in time. The first idea was, in the 90s, we just built data warehouses. We used on-prem systems, really big SMP machines, and we built data warehouses, right? And this is all structured data for the most part. Then, Hadoop appeared, and people started to collect more unstructured stuff, or semi-structured for the most part, really. And then the idea of a data lake came up. Oh, we have all this data that doesn't really fit into an enterprise data warehouse, but people are doing stuff with it, and storage is cheap now. We could even like query it on demand if we really wanted to with this newer stuff like Hadoop or Spark, right? And then we came up with the idea of a data lake and data warehouse. Now, if you have a data warehouse and you have a data lake, that doesn't mean you have a lake house. A lot of people are using that term for that. That's not what that means. The lake house is a fairly new term popularized by the company Databricks that creates the Databricks product. And the idea of the actual lake house is that you use some of the Spark um, table types that have been developed as independent projects, such as Apache Iceberg, Hootie, or the Delta table open source project from Databricks, and you get rid of your structure warehouse, basically. So it's saying, look, Parquet is really fast, cloud storage is good now, Spark has grown to the point where it can do the workload of a data warehouse now. So forget about having a data warehouse. Just keep the data lake, connect, a modern implementation of Spark into it, and use Parquet and some of these advanced table libraries like the Delta tables to get behavior similar to what you would get from a full warehousing product, right? So we have things like Delta tables that even though they're in cloud storage, they can do ACID transactions, they can do time travel, they can keep lineage information. They allow you to, have partitioning on the Spark layer and so on. You can even do streaming into them now, right? So all this kind of stuff. So this is what the lake house is. Um, I think it's a good idea. I like it in concept. I find that most people will still do a combination of these, so they don't really do a pure lake house per se. Um, and even if you were to go like, let's say, pure lake house, to me, some of the way that it still works, especially to me, the best way to run Spark today would be to use Databricks. Um, and even when you use Databricks, it's still not quite the same. It still has some issues. It still has some limits on what you can do in terms of caching, on the speed of the SQL, um, on some of the user friendliness of the tooling, and things that they still need to get worked on. For example, you still can't do on Delta tables, you still can't do a multi-table transaction, things like that. It's getting really close to where it can replace the data warehouse, but I don't think it's quite there yet. All right. So, yeah, this is what people recommend for a lake house is you just put everything in the data lake. It could be structured, it could be text, it could be unstructured. Put it all in a cloud storage data lake. Use one of the advanced formats here, like I mentioned, either Iceberg, Hootie, or Delta tables, and then just use Spark for everything, right? Data lakehouse architecture, where you bring in raw data, more known as like the bronze type of table, then you process it a little bit. That's called like the silver table. This is the type of methodology that Databricks advocates for. You have different versions of the data: bronze, silver, gold, and gold is what is considered like, the reference data set that you can give to people to visualize and analyze with. Okay. So lessons learned here: choosing the right file. From my opinion, you have to, at this point, I would just go with Delta tables with Parquet. Select technologies that are married, that are really well integrated, right? If you're gonna go with Lakehouse, you could just select Databricks. But if you're not gonna select Databricks, then at least select some other technologies that are well integrated. For example, Synapse integrates really well with Spark. You want to do the transformations, right? You don't want to do ETL, you want to do ELT. And this is one of the parts where I find that it's hard to compete with the data warehouse still, is the ad hoc querying on Spark. I still find it a little bit slower. Even with partitioning, it's kind of meets all the ad hoc cases. And it's easier to use different tables materialized in different ways to try to meet different query patterns that people are using. Okay. Finally, I want to go through this data mesh idea, right? So this is copied from the official data mesh article by Zamak Dignani from ThoughtWorks. And the idea is that instead of having centralized warehouses, we're going to have data meshes, and everything's going to be federated, right? So the data ownership is going to be distributed. This part, to me, by the way, to me makes sense. Everybody's going to develop data products. So HR will have data products, finance will have data products, sales will have data products. And then they all will have some sort of infrastructure that they will use to create all these data products from the data sources. And then that way, the governance is all federated, right? So every domain will own its own data, all to the point that they even own how they present their data to the rest of the company or to the outside world. Now, in my opinion, a lot of this is not practical for many companies. Having domain driven data owners, I think, is the main idea inside data mesh that I really like. Also, having data exposed as products, I think, is a really great idea. I'm not really sure about completely, federated development where, HR suddenly has people that can do data development or data engineering and stuff like that. I don't think that's really feasible for most companies. But I do like some of the ideas inside data mesh, like, everybody in the company, HR should have somebody that is, the data steward for HR, for example. I like that. Um, that the data engineering team of the company, a centralized data engineering team, could work with that data steward to define an official, HR data product. I like that idea as well. Where I don't think is really feasible is where literally each one of these different parts of an enterprise are going to be staffed with people that will be creating the data products, right? So the HR data engineers, they just dedicate themselves to that. And then the finance data engineers, they just do that. And that way it's really completely federated. I don't think that's doable for smaller enterprises. Even for bigger enterprises, I don't know if there's really that much benefit to that. Microsoft has an architecture for this as well, for doing the data mesh, right? And it basically just becomes a web of different Azure subscriptions and resource groups that are deployed by different groups inside a company, right? And you can see here, right, where we have all these different, what Microsoft calls different nodes, and each one of these nodes, let's say, for example, this is sales, then they will expose different data products, right? And then inside each node, there's a bunch of different things, right? So each one of them will have their own data lake. Each one, you can see here, even Microsoft says each one of them could have like their own Databricks, their own Synapse, right? This is where I mentioned that I don't think is practical for a smaller organization, even for medium-sized organizations, where everybody will have their own thing, right? Instead of having their one data lake and one big MPP warehouse, everybody has their own data lake and then their own data warehouses, and then they just create these data products. It's very complex in terms of admin as well to be doing it this way, right? So that's my main um, caveat, I would say, to this whole data mesh idea that gets thrown around, and everybody now is just saying, "Oh, you got to do data mesh, data mesh, data mesh." I've been seeing it online tons these days. To me, the real true value of data mesh is to try to get owners from all over the business to own their data that they produce, and to try to structure data as products for the rest of the business. This idea of creating all these like little hubs of a bunch of repeated infrastructure and whatnot, I that's the part that I don't really buy into. All right, regardless, the few clients that we have been working with prototyping and starting to stand up their data mesh practices, it has been a cultural thing rather than technology. The technology is there, but it's a different way of working in terms of culture, right? In terms of how you think about things, in terms of allocating resources. You definitely need savvy engineers to try to pull this off. Again, that sometimes this is hard to do, hard to find the people to do it. It works. I would say I think it would work for a large organization, and that's where it would be most suitable. I don't think you need to follow the hype and get rid of like the basic architectures that we saw today, just because you hear this buzz term of data mesh. If you're not don't have the maturity level that you think, or you don't think that you're getting the issues that might be fixed by using something like data mesh, then don't even bother with this. Again, the IT industry loves buzzwords, and to me this is kind of a buzzword right now. And the whole idea that native veg is built on, again, is zones working independently. It's like, oh yes, all these people, all these for example, all these nodes can be working independently in their own data products, whatever. Once you actually get to real life, it actually is a really big challenge, because what happens is they start to consume data from each other, and they start to build dependencies on each other. So what happens is that if one of them has an outage, then you're affected by it too. Or if one of them has, you want to get your data quicker, but it doesn't match the cadence of another data product from another team, then now you're limited as well by it. So again, it works really nice in paper, but once you get going and try to make it work in reality, you start seeing how this is like an ideal thing, but in practical terms, it has some really big difficulties. Okay. All right, final considerations as we're coming up on the hour. Lessons learned in general from most of these architectures. Clients care about the outcome, they care about the cost, they don't care about the tech details that much unless you miss the outcome and or the cost, right? So you not I don't spend a ton of time trying to explain every single tech detail to the stakeholders what they might be, but I definitely want to make sure that I match requirements, that I match budget, that I match timelines, and the clients, they can trust you, they can trust your expertise and know that you're doing the right tech choices. Definitely more projects are coming on the cloud for analytics than on-prem. I mentioned that already. Don't underestimate the supporting components, identity, networking, security, all that. Super important to get it right. You want the people that know these very well if you don't know them very well. Myself, like I said, I surround myself with people that know a lot about like networking and IAM and stuff like that, because those are things that I personally, I don't consider myself an expert in. Okay, start with core services, core data zones. Maybe you just want to do separation by storage accounts. That's fine. Only expand if you are driven by client requirements. Don't fall into the buzzword, don't fall into the hype. Make sure you know why you're doing what you are doing. Feel free to mix architecture patterns. Maybe you like a little piece of something, maybe you grab an idea of something, maybe you want to do, you like some of the stuff of data mesh. Like I said, think about data products, try to specify data products, um, try to get some people to actually become domain owners, stuff like that, and mix it with some of the basic architectures. That's probably better than going all out on this whole data mesh crazy idea, for example. But that's just one example, right? In general, you probably will see things you like from some architectures. Feel free to create something that really matches your requirements. You don't have to just copy paste the reference architecture all the time. Okay. And that's it for actually for the material for today. I don't know if we have any questions. i can um, I can definitely answer.
Yes, I was on a mute. Can you hear me,
Yep.
everybody? Yeah, great. So thank you for an engaging presentation and talking about components of the architecture. But we have actually a couple questions that I will bring into the studio. So first question comes from Ramon, and here's the question: How to pull data from Purview into Power BI?
How to pull data from? I don't know. I haven't tried that yet. I don't know if does it work. If the Purview catalog. I don't really know. I haven't tried that. That's really specific.
All right. Okay, let's look at the next question here from Mohammed saying in Power BI Premium, we have capacity premium, which include analysis services. It is the same thing as analysis services, or is
Yeah,
not
it is the same thing. Yeah, it is the same thing.
the
Actually,
same
the
thing?
yeah the Power BI in general, the Power BI that you see, like when you import data into Power BI, behind the scenes is actually analysis tabular models, right? It's the same technology, right? Microsoft obviously owns analysis services and they own Power BI,
Hmm.
so it is the same thing. Yeah.
Okay, great. So another question asks that uh, can we use Databricks streaming to ingest data directly to the web app?
So Databricks streaming is for streaming data into your Delta tables in Databricks in cloud storage. It's not for streaming data out, right? If you wanted to stream data out, I would use something else, right? You could create some sort of um, Databricks job, like a Databricks workflow, or a job somewhere else that just grabs. If you wanted to take data from Databricks and put it out, in the example, there it didn't say how the data was getting put into Cosmos DB, but there is a connector. For example, in this case, there's a connector for Cosmos DB for Databricks, right? So you would have, let's say, every 5 minutes or something like that, there could be a Databricks job that takes the data that you want from Databricks and puts it into Cosmos DB, and then the web app grabs it from Cosmos DB, right? Because Databricks and Spark in general is not built for the concurrency of a web app, right? Like a web app, you might be thinking, 50,000 users are using it, whereas Spark clusters, you can only run so many jobs in a Spark cluster, right? If you have, let's say, a Spark cluster with 5 nodes, and each person is only getting 2 nodes, then you're only getting, 2 jobs running at a given time, right? Spark is not built for that. So that's why you need something else in between. For example, if you wanted to feed a web app, Cosmos DB is a good example because Cosmos DB, you know, can scale to like thousands of users at once.
Yeah, and just to add to that, Warner, there's also Azure Stream Analytics.
Yes.
So would that service help here or not in Azure?
It could. So Stream Analytics, the way that Stream Analytics works is that Stream Analytics reads from a source. It could be like an event hub, or it could be storage as well. Does some computation on the fly, and then it forwards that into something else.
Hmm.
And then that something else can be a database. You could use something like an Azure SQL database, for example. And then the Azure SQL database would be the component where the web apps are connecting. And again, a SQL database can support, thousands of connections at once and thousands of users through connection pooling, right? Unlike I said, like Spark is not built for that, right? And cloud storage is not built for that either, right? Even if you had a file that had exactly the data that you want to put in the web app, you're not going to be connecting directly to cloud storage from thousands of web app users, right?
Yeah. So thank you. And we have one more question here from Kevin saying, does Microsoft architecture encourage the use of Data Vault 2?
I don't know if they encourage the use of Data Vault. I mean, you can. I think nowadays it used to be that people would say like, "Oh, this is a particular system is better suited for Data Vault than others." And like other engines. For example, in SQL Server, people used to say, "Oh, well, SQL Server it's not really good for Data Vault. It's not optimized for Data Vault." It's really for like star schema. The optimizations that it has are for star schema style queries. Oracle, I think, has more that people thought would be more for data vault kind of thing. But nowadays, I don't think it really matters. I mean, I've had clients that do data vaults in any of these cloud MPP warehouses, and it seems to work just fine. Some of them do star schemas instead. The choice I don't think is about technology anymore. It's about what you want to use in terms of your methodology, right? I think you can be successful doing like Kimball style star schemas, or you can be successful with data vaults too, if you know why you're picking one over the other, right? And if you have people, if you have data modelers in your company that really are good at data vault, then you want to leverage that, right? If you have the analysts in your a company that are just really good at star schema decomposition, then you want to go that way, right? It's not really much about the technology anymore. So I don't think that the architecture really encourages either one or the other. I think that choice of what methodology you want to use for the modeling and the architecture is more about just your company specific. Yeah.
Okay, and the skill specific, right?
Yeah, exactly.
Great. So, and one last question here, actually, two more arrived. So that's about it's asking for your opinion in terms of is there any supporting tools which can help design Azure data architecture? It is very vague question, but is there any way that they can start when they they are starting into the new project and they want to review existing or updated Azure data architecture
Yeah,
tools,
yeah, definitely. Just use the those what's it called, the reference
architectures?
links. Yeah, the ones that I mentioned before on the presentation. Microsoft, if you go
Mm-hmm.
right now on Google, just search for Azure Architecture Center, you'll be able to find it.
Mm-hmm.
And it has some really good resources, right? So if you want, just go ahead and just go on Google and again just search for Azure Architecture Center, and it will show you the all the different architectures you can search. It'll pull up the diagram. Some of them even have like the templates to deploy them if you want to deploy them from online directly. Obviously, they'll cost you money, but uh, but it is doable. And in terms of diagramming, I mean, there's so many choices, right? Some people use the Excalibur draw, which is free. I've used Lucid Chart before. Um, yeah, there
Mm-hmm.
it is. Thanks a lot. Thanks a lot, Duncan. And what else? Well, if you want to pay, it's not too expensive, but Visual Paradigm is really good. I think Visual Paradigm starts are only like the cheapest one is only like $6 a month or something like that. So it's pretty good. And it has a lot of diagramming and options. And it doesn't just do Azure, for example. If you go with something like Lucid Chart or Visual Paradigm, which you have to pay, but it's not
Mm-hmm.
too expensive, they have all the icons and stuff for AWS. They have all the icons and stuff for Google Cloud. So the actual, you look at the architecture examples on the Architecture Center, and then with a good diagramming tool, um, I find that that helps a lot, to start modifying and creating your own thing.
Yeah, that's really good. And for any architecture, Azure related architecture, that's the site that Microsoft created for everybody to look and kind of get some references. And it's a good starting point. So thank you, Warner, for mentioning that. And I just put the link there. So if you want to check it out, it's there in the chat. All right, that wraps it up. Thank you again, Warner Chaves, for this presentation. I think it was engaging. You put a lot of effort into explaining why and when you want to use that technology based on the uh, trade-offs, right? That you want to make in your architecture and approach for the client solution, and try to avoid the buzzwords and buzz technology because that will make troubles, right? It can
Oh,
bring
we
you
and we
into
and we know
somewhere.
people in IT love their
Yes.
buzzwords, right? A few years ago, it was everybody's got to be doing big data, and then it was
Yes.
everybody's got to be doing ML. Now this year, everybody's got to be doing data mesh, and now just like 3 weeks ago, I read this thing from Gardner, and there's a new buzzword. It's called data fabric. Have you heard about this one, Elkan? Data fabric is new.
I know that there was a service fabric with Azure, which is very
Oh no, but
classic,
this is
but
total.
I
This is
don't know, I
different.
didn't
This
hear
is,
about data
yeah.
fabric
The
yet. Yeah.
Google it after we're done with this call. Google it. It's the new
Yes.
buzzword. I think they want to replace data mesh. Data mesh is so 2021. So now they're coming up with this idea of data fabric too. I was reading about it the other day. I'm like, man, this just doesn't stop. The buzzwords never end. So yeah, make sure that you know why you're doing the buzzword if you are doing the buzzword.
Yes, and that's our really very good recommendations. Again, thank you everyone who tuned in for today's session on Cloud Launch and Learn, and thank you to our presenter, Warner Chavez, for again engaging and meaningful presentation. It was really good. And there is last minute question, of course. Let me bring it to the studio, and then we'll wrap it up. Okay, this is the last one from Ramon. Can we reach out or to check with preview Power BI? So I didn't understand the question. Maybe you know what Chavez the user mean here.
Well, no, I just use any of my contact info, Raman. If you want to go into it in detail, you can use Warner at createdatapros.com or just connect with me on LinkedIn as well. and we can chat about stuff.
Yeah, that's great. Thank you again. And again, everybody, thank you for tuning in. That was really a good session. The Chavez went into whys, not just whats, and we also had some good back and forth questions here, questions and answers. So enjoy the rest of your day, and thank you again, Chavez. Thank you, Warner Chavez, and thank you everyone for tuning
Thanks,
in.
everybody.
Check out check out our next sessions, and thank you. Take care.
Bye bye.